Hey, it's that time of the day. Let's do some math here. Hopefully, I can get that fly.
Okay, first part on this axis provided, sketch the slope field for the 6 indicator points, those 6. So we've got the points 0, 2, 0, 1, and 0, 0. And then same points, 2, 2, 2, 1, and 2, 0. And the slope here, when x is 0 and y is 2, looks like 4, -4. And when x is 0 and y is 1, you get -1. And anytime y is 0, the slope is going to be 0. And for 2, 2, it's 4 over 1, which is positive 4. And 2, 1 is 4 over I'm sorry, 2, 1 is 1 over 1, which is 1. Okay, that took me some time to think. So at this point, 0, 2, we want the slope to be -4. So down 4 over 1. So we're going to have to aim for this 1/2 mark. And -1 and 0. Aim for 1/2 there. Okay, there. That's probably 2 points, I don't know. Sketching the slope field. For 2, y equals f of x is the particular solution, but we're finding the particular solution on C. So we've got an initial condition of the point 2, 3. Write the equation for a line tangent at x equals 2. Use it to approximate. Okay, so looks like all we need is a slope and the slope at, oops. And the point 2, 3 is 3 squared over 2 minus 1, which is 9. Okay, so the equation is y minus 3 equals 9 times x minus 2. And then we're going to use it to find the y value, an approximate y value when x is 2.1. So f of 2.1 is approximately that. So it looks like it's 3.9. Okay, and oops, there. And for C, we want to take this equation, separate the variables, and solve for the particular solution y equals f of x. So y in terms of x. So for C, we're going to start with dy dx is y squared over x minus 1. So when you separate the variables, this y to the positive 2, you divide by y squared on both sides and get y to the -2. dy is 1 over x minus 1 dx. okay? What lots of people do, the mistake people would make is, since this is 1 over y squared, they're thinking natural log, but this is the only side that has a natural log. This, when you add 1 to the power, you get -1, which is a fine number, right? And subtract 1 from the power, no, and divide by the new power. So we're dividing by -1. So this is y to the -1 divided by -1, which is -1 over y. That equals the natural log of the absolute value of x minus 1 plus c, okay? And exactly after you integrate both sides, that's when you use the initial condition. So at the point 2, 3, -1 over 3 is the natural log of 2 minus 1 plus c. So it looks like c is -1/3 because the natural log of 1 is 0, right? Because with logs, natural log is actually log base e of 1. And remember, logs are powers. What's the power you put on e to get 1? E to what power equals 1? And of course, that's 0. So the natural log of 1 is 0. Okay? Now we have this equation. It's that one. -1 over y equals the natural log of the absolute value of x minus 1 minus 1/3. Okay? We're going to solve for y. I suppose it doesn't have to be beautiful on a free response question. It just has to be correct. So what if we flipped both sides of the equal sign and we got y, I guess that's -y now, equals 1 over this. And then y is -1 over this. Okay. And that is a great answer. Okay, so let's look at the scoring guidelines. 2 points. 1 point for the zero slopes for those two, right? And 1 point for the non-zero slopes, so -4 and +4, -1 and +1. It's nice that if you have it listed so they don't have a question about what you mean, right? In the second section, it's 2 points again. 1 point for the equation of the tangent line, right? And we have it right there. There. And 1 point for the approximation. And then the last part, it's 5 points. Oops, let's see here. Let's get that on there. Okay, so 1 point for separating the variables. We did that here. 1 point for taking antiderivatives. And I assume if you get this side right and that side wrong, you'll get 1 point. 1 point for the constant of integration and using the initial condition, right? And then rewriting your equation here and solving for y. And solves for y is the last point. So there you go. Hope this makes sense. Have a great day.